Does the atmosphere need fixing?
To answer this question, we focus our research on the ozone layer, which makes up Earth's atmosphere.
The ozone layer is a colorless, unstable, toxic gas with a pungent odor and powerful oxidizing properties, formed from oxygen by electrical discharges or ultraviolet light. It differs from normal oxygen gas in having 3 atoms in its molecule.
It does not come as a surprise to many that the ozone layer went into depletion several years ago. In 1979, it was confirmed by NASA that there is an immense hole in the ozone layer above Antarctica.
The hole in the ozone layer is over the Antarctic because of the special atmosphere and chemical conditions that exist there and nowhere else on the globe. The very low temperatures of the Antarctic stratosphere cause polar stratospheric clouds to form.
It is theorized that this hole was caused by the release of CFCs into the atmosphere.
CFC is short for chlorofluorocarbons, any class of compounds of carbons, hydrogen, chlorine, and fluorine, typically gases used in refrigerants and aerosol propellants. They are harmful to the ozone layer in the Earth's atmosphere owing to the release of chlorine atoms upon exposure to ultraviolet radiation.
Through strong chemical reactions, these gases cause the ozone molecules to break down, reducing ultraviolet radiation absorbing capacity.
The CFCs are bombarded by ultraviolet light that result in the release of a single chlorine particle. This chlorine particle bonds with a single oxygen atom from an ozone molecule, forming carbon monoxide and oxygen gas.
This carbon monoxide molecule bonds with a random oxygen atom produced by ultraviolet light and the ozone to form O2 and a single chlorine atom. This chlorine now has the ability to strike again and repeat the process over and over again, thus leading to ozone depletion.
The destructive nature of CFCs have been combated by the ban of the use of CFCs in products.
The replacement for CFCs are mainly halogenyl alkanes and sometimes simple alkanes such as butane. The halogenyl alkanes are carbon compounds that contain hydrogen as well as halogen atoms.
These have a shorter life in the atmosphere than CFCs, and the majority are destroyed in the low atmosphere as to not affect the ozone layer.
Because of this ban on CFCs, the ozone layer has had an opportunity to revitalize and reproduce itself. It is even suspected by the next century the ozone hole will be gone for good.
With there being little to no more CFCs in the environment, instead of bonding with chlorine from the CFCs, the ultraviolet light and ozone generated oxygen can bond in groups of 3, thus creating more ozone.
This being said, as the ozone hole closes, it will trap more heat into the environment, therefore having an adverse effect on global warming.
Think of the amount of ozone as a water level in a cup with a small hole in the bottom and a tap faucet adding water at the top. When you turn on the water, you'll find a balance point where the amount of water in the cup stays constant, even though the faucet is adding water and the hole is removing it. The addition and removal are happening at the same rate, so the water level stays the same. Now pour in a glass of water. You'll see that the water just drains faster for a little while until the level returns to the previous depth. The balance is stable. That's because with more water in the sink, there's more pressure at the bottom, and the water drains faster. In the same way, if you dump more ozone into the ozone layer, the destruction process will speed up a little bit until the amount of ozone returns to the stable point.
To conclude, the atmosphere does need fixing.
Although it can and will fix itself.
With some help from us, of course.